Hello everyone. The topic that we are going to cover throughout this lesson is the volume regarding to the parallel y-axis. Okay, so what we have done, we usually have this this kind of shape, say in between A to B, rotate about the x-axis. It is like delta volume is regarding to the delta x here because rotated by x-axis here. Okay. And then what we're going to do now, we're going to make a shape. So C to D will rotate about the y-axis. So then delta volume is regarding to delta y. Okay, so that is how you determine whether it is a delta x or delta y. Okay, the other way that you can find either delta y or delta x or delta y is this one. We have a little, so the shape, we're going to rotate about this one. For the delta volume is measured like this one. So that is the thickness. Okay, thickness is parallel to x-axis. Then we can say, oh, that is delta x. Similar here, we rotate about the y-axis. We are expecting to have this sort of 3D shape. Then the delta v, so just say one of the units. The volume of the shape is parallel to y-axis, then we can say delta y. So that's how you can remember. Either way is okay, but I suggest you to remember both of them. Okay, so that you can get covered either one or the other. So that's the basic idea about what we are going to do. Of course, this volume requires extensive knowledge of the integration. So make sure your integration skills are up to date, okay? Not that crappy. We do the question here, right? The region bounded by this parabola, and the x-axis rotate about. The x equals to 2, okay? So when you sketch the diagram, rotate about. The x equals to 2 there. So then it is parallel to y-axis. So it is not exactly y-axis, but this axis, which is x equals to 2, is parallel to y-axis. So it is moving that way, okay? The next step in the diagram is to sketch the delta v. So sketch the delta v is this one. We have one of the slice, and then the thickness, okay? Can you see the thickness? The thickness, the thickness is parallel to the y-axis. Then we can name it as delta y. Does it make sense? I've spoken to you just a few minutes ago. And then we point this is xy, okay? Well, it's entirely up to you guys. You can point this one, well, let's say that equals the point that we are looking for, that's okay, but only one or the other. Depending on what you need to choose, okay, what you can choose, the expression will get changed. So I like to get this point is x and y rather than this left-hand side, okay? So see what's going on. Now, delta volume. Okay, this delta volume is basically the area of the circle times by the height, which is thickness, in this case, delta y. That's what you're going to do. How you find the area of the circle is basically try to find out the radius. What is that radius? In this diagram, so we have x there, and then that is 2. So basically, x minus 2 is the length of the radius. Does that make sense, guys? Okay, does it make sense? Yes. Now, so that's what the pi r square, area of the circle, and times what delta y, which is the thickness of the slice. So then that is the unit, one of the unit, the slice, okay, volume of the slice, okay. And then delta v in terms of y, but that is in terms of x. Well, this is y, so this expression should be converted to y rather than x, because we cannot integrate, we cannot differentiate later on. Okay, basically we cannot integrate it. Okay, we have to integrate in terms of y, but this is written in terms of x, which is we can't move forward. Now we've got to start using the equation of the parabola over there. So we try to make similar to this one. Okay, so what I like to do, we're going to rearrange here, so plus 4 minus 4, which happens nothing. Why we do that? We're going to make it completing the square over there, okay? So that bit will get factorized like this by the completing the square, and a plus 4 is just there. oh, okay, so what I like to do, x minus 2 squared equals to 4 minus y. This will replace that. So then, everything written in terms of y, so this is what we want. That's what the question asks us to find out. All making sense, guys? Okay, so I explained you about how to find the volume, and then how you can identify with the delta x or delta y. Okay, so depending on the shape of majority of the question we're doing today is rotate about the parallel to y-axis. It must be delta y at the end. Okay. Now part B, the region bounded by that parabola, which is the same question, rotate about the x equals to find the volume of the solid. So we eventually try to find the volume of that. Okay, so volume equals to, okay, say thickness. The thickness as thin as possible, the more accurate of the real volume value is. Okay, so that's why we're trying to delta y is almost 0, and we're going to find the limit value, and then we're going to add all of the tiny little slices up from y equal to 0 to 4. So there are lots of slices till 0 to 4. We're going to add everything while delta y is almost 0. It just has almost nothing, but there's a very tiny little thickness. Then this is equivalent integration notation here. So all of this is changing to 0 to 4, the integration, and delta y is converted to dy, which becomes usual integration. Now it's just a very simple integration. Okay, so plus 1, and then substitute 4 and 0, and then calculate. It comes out as 8 pi unit cubed. Do you get me? So it's just a simple question. So mostly for this question, the question 1 is having part A and part B. However, usually just one question. So find the volume of this solid of revolution in this circumstance. Okay, and then you have to find out proper expression of the delta volume, and then put them into the integration by use the limit and sigma notation, and then calculate it. Okay, so that's the first question. Second question. This question requires us to find out a few evaluate the values beforehand, so that you can use all of the small little values at the end for accumulating all of the value into find the one single volume in an area of the volume. Volume values. Okay, we'll calculate this one. Okay, evaluate this. So x times cos x. How do you start the integration? Well, can anyone tell me? Yeah, it is a good candidate of using the integration by part. So you're gonna say u v dash. Okay, we're gonna do u v dash. Make sense? So we're gonna have a good setup for the integration by part. So u v dash. So we're gonna assuming that is u, and then cos x is v dash, and then differentiate u dash is 1, integrate cos x is sin x. So we have a good setup. Okay, so we can put everything. So that is u v minus u dash v. Make sense? That's the basic rule of the integration by part. Put them in. Okay, everything is that equals to uv. Okay, so uv, which is that, and then that is u dash v. Okay, so u dash v, which is 1 times sin x, which is just sin x, and then put all of the limit values, and now we can calculate. But that one, integral of sine is negative cos, so the negative one becomes positive. Substitute all of the values here, everyone. Okay, so the pi on 2, sine pi on 2 equals to 1, so that becomes as pi on 2, and then cos pi on 2 minus cos 0. Make sure it's a very typical mistake. It's very ridiculous mistake. People make cos 0. They don't even want to substitute because 0 is nothing. But make sure cos 0 is 1. Cos 0 is 1, okay? So it's very ridiculous mistake. I really don't want this to happen to you. So whatever is 0, always write them, okay, before you proceed the next steps. Otherwise, you will encounter silly mistake. But after all, you find your answer was wrong, and it is very difficult to find this sort of silly mistake out later on. So therefore, just do take the steps only one at a time, not doing anything in your brain. Okay, I don't want to tell you don't trust your brain, but brain is designed to make a kind of this sort of a tricky mistake. So you have to overcome that sort of mistake. Okay, so cos 0 is 1, and then cos pi on 2 equals to 0. Okay, so that's what we should have. Does that make sense? So we find the first one, and the second one, evaluate again. We will have to use the integration by part again. So that's uv dash. Is a good setup? Yeah, it is. So uv dash and then u dash v. Okay. I don't believe any one of you having trouble in setting a good integration by parts. Okay, so we'll go for it. If you can't remember, or if you are having some difficulties in handling with integration by part, please go back to the video lessons regarding to the integration by part. Take some time and to get used to it, to have a good understanding, and come back. So that will be the probably best idea. Okay, so we'll still move on. I'm going to use this integration by part, uv. So that integration that's uv, okay? Minus u dash v, so minus, it becomes plus, okay? And then integrate of cos is just simply sine, okay? So minus sine of cos over here. So substitute all of the values, okay? That equal to 0. That is 1. Does it make sense? That is 1. Okay, so integrate of cos is just positive sine x, as can here. Substitute everything. Okay, so 0 times 1 equals to 9, so all gone. The only this is left over. So sine pi on 2, 1. Sine 0, 0. So therefore 2 times 1, which is just 2. Okay, so that's the easy values, but don't make any silly mistake. Jump on to part C. Evaluate x squared cos x. Again, would you mind to use the integration by part again? Yes, please proceed. Have a good setup. U v dash. Okay, so u v dash, and then you differentiate it. It becomes 2x, and integrate cos x becomes sin x. Okay, and put them into this formula. Okay, so substitute. That one, okay, we have calculated this one already in part B. Okay, so that was 2. So we can substitute pi on 2 and 0. So that's 1. So pi squared on 4 minus 2 is the value for part C. Easy. Now, part D, okay, the region under y equals to sin x, bounded by the x-axis and the x equals to pi, is rotate about the x equals to pi on 2. Yeah, it asks us to find out the expression of the volume. What do you need to do? Sketch the diagram. Okay, sketch the diagram as accurately as possible. And then it rotates about x equals to pi on 2, everyone. Okay, and then what's next thing that you have to sketch? Yeah, slice. Okay, you have to draw this one good slice, and then the thickness. Okay, I explain about the thickness about a few minutes ago. That thickness is parallel to the y-axis, therefore it should be as delta y. Okay, now that equals to xy. Okay, so we've got to find out the radius. What was the radius? So that is x. So x minus pi on 2 is that, which is the length of the radius here. Does it make sense, right? So then we can write over here, say pi r squared. So pi times the radius squared, and then times the thickness, which is the volume of the unit delta volume. Okay, that's the delta volume. Okay, the volume of the unit kind of slice, and then that volume is basically put them into the integration. Okay, I just skip the process here using the with the limit. Okay, delta y becomes 0. Integration y equal to 0 to 1. So that is replaced by complete integration with the two limit values, 0 and 1. Okay, that's the same thing. And the next step is to expand it. Then that becomes the stuff that we have to prove throughout this question. All okay, guys? Yes. And then next final step. Okay, final step is to actually calculate this one, evaluate it. Okay, we're gonna separate them out, just one at a time. So we're gonna here, okay, so take that out, okay, and then that is going out, so cos x there, and then that times cos x, that time x squared times cos x, everything. Okay, we just make it simplify. And then we have those two values already in the preceding questions. Okay, so we found those values over here, and the integrate of cos is sine x, and then in between pi on 2 and 0. Easy. Okay, it's so easy, guys. Okay, now you can put them in. Okay, you can put it in. Sine 0 equals 0, sine pi on 2 equals to 1. So simplify, you will get the final result. It's not too hard, but mostly this question is just one big piece. But I just separate them into little 5 steps, so that you can have a better understanding of how you do the longer ones. Okay, so that's pretty much it. In the I covered the methodology to find out the volume, which is rotate about the parallel to the y-axis. Particularly for this question, rotate. We just found out the volume rotate about x equals to pi on 2. Okay. Hope everyone has a good understanding now. Okay. We'll talk to you at the next lesson.